A function is defined by g of x equals to 3x cubed minus 4k squared x plus 5, where k is a positive number. K is a positive number. So we need to keep that in mind. Now they tell me determine the value of values of x. The values of x in terms of k for which the function is decreasing. Decreasing, we make derivative equals to 0. So we derive that one. So we can even write let g prime of x equals to 0. So when we derive, I've got 9x squared minus 8 minus 8k. No, it's not minus 8k, it's wrong. Because the power we're looking at that x here. So it's going to be minus 4k squared. Sorry about that. The next one is a constant. Nothing else will make that equal to 0. So this is difference of two squares. We can even transpose and divide. It's the same thing. If you see difference of two squared, that means you're going to write that as 3x plus 2k. You repeat the same thing, but with a reversed sign, like that, equals to 0. The first one is going to be 3x equals to negative 2k. So therefore, x equals to negative 2k over the third. That's the first one. The other one, I believe, will have a plus. This one is going to be 3k over the 3x equals to positive 2k. And then we can write that x equals to 2k over the 3. Now, they said something to me. They said determine the value of values of x in terms of k. So it's fine here. It's fine. These are the values. Okay, let's look at the next thing. All right, so this is alphabet B. Alphabet B says in the diagram below, the graphs, plural of G hyperbola, which is this one. They did not show the other part because they're saying for x is less than, and we're working by the negative side. By the negative side. Okay. So, and then it says, and f of x equals to x cubed minus 3x plus t are given. Hyperbola and a cubic graph. They say the graph of G, hyperbola, has an x-intercept here at that point. So that is x-intercept here, which is that line. So I'm going to put it, which is that one. So x is negative 2, semicolon, 0 for the x. graph G and F have a common y-intercept. The y-intercept is the same. It's right there. So it's going to be 0, semicolon, minus 2. All right, now they're telling me determine the values of A and Q. Okay. I must find the value of A and Q. First, I've got x-intercept. So I'm going to substitute x-intercept into this formula. So I'm going to write before 2 when x is minus 2, y 0. So that means I have an equation that says 0 for the y equals to a, and then the x will be minus 2, and then minus 1, and then plus the q. That will be the first equation. Remember down here, it's actually minus 3. It must come multiplied there, 0. So it will be 0 equals to a. It will multiply the q, minus 3q. I just multiply by minus 3 everywhere. All right, then from this I can now write that a equals to 3q. From that first part. The second part, I must substitute the next point. 0 and minus 2. By y it's minus 2, by x is 0. So I'm repeating the equation. By y is negative 2, but now by x is 0. So I've got 0 minus 1, and then plus q. At the bottom is a minus 1. Minus 1 must times there. So it's going to be plus 2 equals to a. Of course, it will be times the q, that minus 1. Then it's minus q. Well, we are basically arrived. So what I can do, I can take this, I can put it there. Then I've got 2 equals to 3q minus q. You can see you've got 2 equals to 2q. You divide, q equals to 1. And then a equals to 3 times 1, which is 3. All right, so it was simultaneous equation. All right, but so I'm gonna do this. We can now rewrite the equation and say before 2. At the top there it's 3. And then the other side it's gonna be 1 here by the q. Because the chances are we might need that equation. All right, let's see next one. They say determine the values of x for which the graph of f is concave down. Concavity, it's called concavity. Okay, that means here second derivative must be equals to 0. So it means we take that graph, we derive it first and second. So first derivative, f prime x equals to 3x squared minus 3. All right, I know it's saying 10 minutes to you. Then second derivative, f prime prime, it's gonna be 6x. Remember, we make it equals to 0. When I solve for x, then x equals to 0. So it means, but then they ask me for concave downwards, where the graph is curving downwards. it's gonna be the blue portion of the graph. That blue part of the graph. It's on the left-hand side of 0. That means less than 0. So we can just give it to them and say, guys, x is less than 0. There we go. All right, the next one, it says, for what value or values of k would f of x equals to k have three unique real roots? Well, that's a good one, because what we do, we come to this graph. For this to have three different roots, that graph needs to be shifted upwards. We're gonna have to shift it up. So let me kind of show you what we mean. I've got this blue shape here. So there by the turning point where I'm putting a blue circle there. So to have three distinct roots, you must push it up like this. You've got x value here, another one there, another one which is different. But that means the graph must be shifted greater than 0 up, but less than whatever the y value was here. Yeah, the y value here at the turning point here. All right, but they did not give me this graph, this value here. They did not give me that value there, because I want to know what was the turning point. Well, the turning point, I do it by first derivative. So first derivative, there it is, we make it equals to 0. So that means I'm going to take 3x squared minus 3. We make that equals to 0. All right, then divide by 3, x squared minus 1 equals to 0. Then solve for x is going to be plus or minus 1. So for me, where I'm putting the red dot, the x value is on the 1 side. That one is going to be 1 and 0, obvious, because, yeah, that blue one there, the top. Let me shift that minus 2 and whatever. Let's put it here. So you've got a point here, which is minus 1, semicolon, end. Well, take a minus 1. If we take minus 1 and then you were to put it here, it's going to be minus 1 plus, as this will be plus, minus 1 plus 3, minus 1 plus 3. You're left with 2 plus t. So it's going to be 2 plus t. They should have told me in terms of what? And then the other one, if I were to use a positive 1, if I use a positive 1 for the red one, put a positive 1 is 1 minus 3 is going to be minus 2 plus t. There we go. So minus 2 plus t. There we go. So what we know now to have three different roots, because they put k on the other side. I don't know how you do it. You guys, you draw dotted line. So I've got the k. Yeah, I transpose it to the left-hand side to be negative k. So myself, I would say, okay, guys. So I'll bring it together to be there with the t. So I know it will be minus k. So I'll say minus k. I'll write that twice. Then we say shift the graph more than that one, because that y, 2 plus 3, it must be shifted greater than 2 plus t, where upwards. Upwards means I put a positive sign here. And then this one, we must shift the graph less than this amount here. So that means less than negative 2 plus t upwards, which means there. Well, I just solve for that inequality. If I multiply by negative, the first part becomes k is less than negative 2 minus t. That's a red one. The next one, which is purple one, is going to be k will be greater than 2 minus t. Then I know it must be in between. Then you put the k in between like that. You put it in between. You can see it says, this one says k less than. That is the one that comes here, minus 2 minus t. This is say k is greater than. So it's 2 minus t. So this becomes our answer, but in terms of t. All right. But t, to tell the truth, it was the y-intercept, that minus 2 there. So you can put the minus 2 if you want to now. All right, I did it with the 3. So that means if I to put minus 2 there, it's minus, you've got what? Minus is going to be 4. Because remember, you're putting minus 2. It becomes positive. So you got 4 is less than k, less than, then if you put minus 2, it's plus, and then the other one is 0. Something is fishy here. Let me see. Did I change the sign correctly? All right, let's back off here. When I put minus, it's minus and a plus. So it's positive 2t. Yes, it's right. So k must be shifted more than that amount upwards. Yes, it's right. Minus 2 minus 3 t. Yes. So checking the, all right. Then the other one, I had to put a 1, will be minus 3, minus 2 plus t. Yes, it's right. So it must be shifted less than that amount. So when I reverse, it's minus, it's positive, negatives. Yeah. So it's right. So k is greater. Yeah, which is a k is greater than 2 minus t. It's in the right place. And then here k is less than minus 2 minus t. What's bugging me is when I put the value of t here, because I think it was minus 2. Yeah, the y is minus 2. So if the right must actually be bigger than the one on the left. All right, so let's see. Maybe it's me. Put a minus 2 here by t. It become a plus. It's a 4. But if I put it the other side, which is here, it become a plus, it becomes 0. Wow. So k must lie between 0 and minus 4. I'm not liking that because that's not